हेलो एवरीवन, ए वेरी गुड मॉर्निंग ऑल ऑफ यू। कैसे हैं सब लोग? व्हाट्स अप? प्लीज गाइस डू लेट मी नो इफ आई एम ऑडिबल एंड विजिबल टू एवरीवन so that we can start our wonderful session as early as possible. Am I audible and visible to everyone? Those who are watching me live, please respond through the comment section. This is Chandra Shekhar welcoming you all to the India's largest, the best and your favorite live learning platform, that is BYJU'S Exam Prep. How is your preparation going on, guys? So this is the T20 Super Series for all the, which is important for all the engineering aspirants who are going to appear for GATE 2023 examination. In this series, we have brought 20 most important questions, most important concepts which are repeating every year, so that once you are able to understand or revise those concepts beforehand, you will be able to perform very well in your actual examination. Am I audible and visible to everyone? Please do let me know. Can you guys hear me? Shall we start? All right. So this is my quick introduction for those who are attending the session for the very first time. As I said, my name is Chandra Shekhar, mechanical engineering graduate from IIT Delhi. Also cleared engineering services examination. And from last 9+ years or from last 10 years, I am completely into teaching, guiding the students who are preparing for various competitive examination. All right. And the mentioned subject are my preferred subjects for mechanical engineering. So I am here with the heat transfer. There are 20 questions in total. I would like you guys to try attempting those questions. And if you have any difficulty, you can always use the chat box to share your answer, to share your knowledge, as well as to ask your doubts. So those who have not joined me on the Telegram group yet, I would strongly request everyone to be part of my Telegram group, that is Mechanical by Chandra Shekhar. The link is mentioned over the screen, because I will share the PDF of all my sessions on my Telegram group, as well as I provide you the questions for practice and important information will also be shared to you through the Telegram group. All right. Please do let me know if I am audible and visible to everyone. Those who are watching me live, keep on responding through the comment section so that we can start. Shall we start? Keep your pen, notebook and calculator and also try to solve as many questions in minimum possible time with maximum accuracy, so that you will be able to understand your weak areas and you can accordingly you can check your score and you can improve your weak areas. All right. So there is an important workshop which is going to be held on 5th of November. Your favorite Rakesh sir will be taking this session for giving you the preparation tips, preparation strategy for 1 year. That is important for GATE 2024 aspirants. You can join. The registration is completely free and the link for registering yourself for this workshop is already there on the in the description box. All right. Please go through the description box once after the session, or so that you will be able to get all the important links which are there mentioned in the description box. And do not forget to like this session, share this session to all your friends, and subscribe our BYJU'S YouTube channel. All right. So let us start with the first question. The first question is on the screen. And one more important thing, I have not brought the slide for that. Now the GATE and ESE Hindi channel, which was earlier GATE and ESE Hindi channel for BYJU'S, is now it has become mechanical and civil engineering specific channel for GATE and ESE preparation. All right, so there is no Hindi, there is no English separate channels now. One is for mechanical and civil engineers, another is for the remaining branches. So you should subscribe the channel which is for mechanical and civil engineering, so that you will be getting all the updates and notifications for our classes which are going to be held regularly. All right, so there is the first question on the screen. Can you just let me know the answer to this question? In which of the following situation the unsteady state heat conduction problem can be solved by using the lump heat parameter analysis? When can we assume the unsteady state heat conduction as a lumped state system? So there are 5 statements. Out of them, which are the following statements are correct? Thermal conductivity is infinite. For lump system to be valid, K is infinite and H is finite. Very true. Isn't it true? Statement A is correct. K is infinite and H is finite. What about the internal temperature gradients are infinite? That is incorrect, because dt by dx must be 0. Temperature should not be a function of space. Then only, what is the meaning of lump analysis? Temperature is a function of time only. Temperature is not a function of space. So if the temperature is independent of space, the temperature gradient must be 0. So 2 is incorrect. Biot number should be less than equal to 0.01. To be more specific, R conduction is less than equal to 1/10 of convective thermal resistance. So the Biot number should be less than 0.1, not 0.01. Biot number should be less than 0.1. So statement 3 is also incorrect. Statement 3 is also incorrect. What about 4? Conductive thermal resistance should be less than the convective thermal resistance. 4 is correct. The temperature variation with respect to the thickness is negligible. Yes, temperature is not a function of X. 5th is also correct. So 1, 4, 5. 1, 4, 5 are the correct answer. Option B, Nora Fatehi. Option B is the right answer. Isn't it option B? B is the correct answer. 1, 4 and 5 are the correct options. The next question on the screen: for the composite wall shown in figure, this is the figure given, the electrical circuit is given by which of the following options? The electric circuit is given by which of the following options? There are 4 thermal resistances: first, second, third and fourth. There will be 4 thermal resistance in total. So option A, B, C are having the correct circuit diagram. But now if you write the thermal resistance, what is RA or R1? There will be 4. B and C are parallel to each other. This is how it will be shown. Isn't it? So this is R1, this is R2, this is R3 and this is R4. What is R1? R1 is equal to LA upon Ka into A. A is the area which is normal to the direction of heat flow. A will be this area. This is the area which is A. Right? So what about R2? That is LB upon KB into A by 2. This will be the area taken into consideration. We can call it as A by 2. Similarly, R3 will be again LB. The thickness is same, upon Kc into A by 2. And then R4 will be equal to Lc upon Kd into A. Now it will be A. So these will be the value of R1, R2, R3 and R4. Can you find out the correct answer? Can you find out the right answer for the circuit diagram for the given figure? Option B looks correct. Isn't it option B? Option B is the right answer. Isn't it option B? because here area will not be there. Same area will not be there for B and C material. So that cannot be correct. A cannot be correct. Same area cannot be used for all the materials. It is A by 2. This area should be A by 2. This area is A by 2. If it is not given, we can take it as half of area. If we see option C, so L by K is not the thermal resistance. Area is missing. Area is missing. And here the thermal conductivity is not correct. KD will not be there. So option B is the right answer. What about the next question? Find out the answer to the next one. The Nusselt number is related to the Reynolds number in laminar and turbulent flow respectively. For external flow, if we talk about external flow, what is external flow? Flow over a surface, flow over a flat plate, flow over a flat plate. So the external flow can be divided as in two types. One is laminar flow. When do we have? For external flow is analyzed by boundary layer theory. So for laminar boundary layer, Reynolds number should be less than 5 into 10 to the power 5, isn't it? In that case, Nusselt number is directly proportional to Reynolds number to the power 1 by 2 into Prandtl number to the power 1 by 3. And for turbulent boundary layer or turbulent flow, when the Reynolds number is greater than 5 into 10 to the power 5, Nusselt number is proportional to Reynolds number to the power 4 by 5 into Prandtl number to the power 1 by 3. So the question is about the variation of Nusselt number with Reynolds number. What is the correct answer for this? What is the right answer? Tell me. Reynolds number to the power 0.5 for laminar boundary layer and Reynolds number to the power 0.8. 0.5 and 0.8. No option is correct. I think there is a mistake. It should be 0.8 here. 0.5 and 0.8. Which is the correct answer? What is the answer? Option D. D will be the answer. D is the correct answer. If the flow would have been internal, for internal flow in a pipe or a duct, it can be divided as laminar or turbulent. For laminar flow, Nusselt number, that is H into dH by Kf, is equal to constant. The value of constant can be 4.36 or 3.66. Depending on if heat flux is constant, it will be 4.36. And if the surface temperature is constant, then it will be 3.66. For turbulent boundary layer, laminar flow, when the Reynolds number is less than 2000. For turbulent flow, Reynolds number should be greater than 4000. So the Nusselt number is proportional to Reynolds number to the power 4 by 5 into Prandtl number to the power n, and n is equal to 0.4 if Ts is greater than flue temperature, n is equal to 0.3 if Ts is less than flue temperature. These are the formula you need to remember, you need to memorize for internal flow. All right. The next question, question number 4. If average Stanton number, what is the Stanton number? For a laminar flow system is given by this, and the Prandtl number is 0.69. The average skin friction coefficient will be equal to, what is Stanton number? Stanton number, local Stanton number is local Nusselt number divided by local Reynolds number into Prandtl number. For laminar boundary layer, For laminar boundary layer, when the Reynolds number is less than 5 into 10 to the power 5, then Nusselt number is given by 0.332 into Reynolds number to the power 1 by 2 into Prandtl number to the power 1 by 3. That is the exact expression. And CFX is equal to twice of 0.332 upon Reynolds number to the power 1 by 2. These are the formulas. So if you put 0.332 as this, what is 0.332? So if we put the value of Nusselt number from here, then the Stanton number is given by, in place of 0.332, write CFX into Reynolds number to the power 1 by 2 by 2 into Reynolds number to the power 1 by 2 into Prandtl number to the power 1 by 3 upon Reynolds number into Prandtl number. Isn't it? So this Reynolds number to the power 1 by 2 get cancelled out with the Reynolds number. So Stanton number is equal to CFX by 2 into Prandtl number to the power 2 by 3, or CFX is equal to twice of Stanton number into Prandtl number to the power 2 by 3. This will be the expression. If we want average, so we will take Stanton number as average. So it will be 2 into Stanton number average into Prandtl number to the power 2 by 3. That will give you the answer. That is the skin friction coefficient. Can you solve it and do let me know? What is the answer? Put the values and find out the answer. Isn't it option D? Are you guys getting D or not? Are you guys getting option D or not? The next one, question number 5. There are 20 questions in total. Try to solve the next one. A long solid cylinder which is surface 1 of diameter D1 is enclosed by another long cylinder. The question is from the radiation shape factor. There is cylinder which is insulated from inside, and there is another cylinder which is insulated from outside. Let us say it is enclosure. They are cylindrical system, concentric cylinder. If D2 is equal to twice of D1, the percent radiation from surface 2 itself, F22, will be how much? So from the enclosure theorem, we can say F22 is equal to 1 minus F221, and from the reciprocity theorem, we can write F221 is A1 by A2 into F122. Now we need to find out A1 by F122. Also F11 plus F122 is equal to 1 from the enclosure theorem. Self-shape factor of a convex surface is equal to 0. 1 is the convex surface. For a convex surface, so F122 is equal to 1. So F22 will be equal to 1 minus A1 by A2. And what are A1 and A2? A1 is equal to pi into D1L. A2 is equal to pi into D2L. So it will be 1 minus D1 by D2 will give you the answer 50%. 50% will be the answer. Isn't it? Question number 6 on the screen. The thermal conductivity of a plane wall varies as K is equal to K naught 1 plus beta T, where beta is greater than 0. Then which of the following is the temperature profile if beta is greater than 0? For Q to be constant, that is minus Ka into dt by dx, Fourier law. We can say dt by dx, temperature gradient is inversely proportional to K. Temperature gradient is inversely proportional to K. And the heat flow is taking place from left to right. The flow of heat is taking place from left to right. Then as x increases, by using this, as x increases, the temperature must decrease, isn't it? And if we use this expression, if beta is positive, then we can say K will also decrease. And if K decreases, dt by dx must increase in the direction of heat flow, and the nature will be negative. So the curve which represents the negative and increasing slope will be the correct answer for the temperature profile, isn't it? So B is the correct answer. B will be the right answer. So if we draw the temperature profile for a plane wall having constant heat transfer rate and constant temperature difference delta T, then there will be three curves shown. The temperature profile will be linear if K is constant. The temperature profile will be linear for constant thermal conductivity, that is the average thermal conductivity if we take into consideration. The temperature profile will be given by this curve when K is equal to K naught 1 plus beta T, when beta is positive. That happens for gas and insulator. As the temperature increases, the thermal conductivity increases, gas and insulator. And the curve will be given by this graph when K is K naught 1 minus beta T. Again, beta is greater than 0. So this will be valid for liquid and conductor. These are the temperature profile because dt by dx is always inversely proportional to K. The analysis or the expression, the curve will be developed by using this expression. Question number 7. A steam condenser. Condenser means, what is a condenser? It means hot fluid is undergoing a phase change. The temperature of the hot fluid remain constant. Condensing steam at 70 degrees Celsius. The hot fluid temperature TH is 70 degrees Celsius. The temperature profile will be horizontal line to have a capacity of 100 kilowatt, that is Q. Water at 20 degrees Celsius is used. Water is the cold fluid. At 20 degrees Celsius is used and outlet temperature is limited to 45 degrees Celsius. If the overall heat transfer coefficient is 3100, that is U. The surface area required is, the question is about A. Assume water heat capacity as minimum. It will definitely be minimum because the heat capacity CH is infinite. If there is a phase change, then the heat capacity rate for the hot fluid will be taken as infinite. The surface area need to be calculated. Assume the water heat capacity as minimum and use NTU method. In objective paper, it cannot be mentioned whether to use NTU or LMTD approach. Whatever you are comfortable with, you can use the approach if the parameters are sufficient to use any of the methods. So first, let us use LMTD approach. And we will check whether we will get the same answer or not. So for LMTD, we need to find out the LMTD. We can use the counter flow or parallel flow heat exchanger. It does not matter at all. You can either use the parallel flow heat exchanger or counter flow heat exchanger. It does not matter. The hot fluid temperature remains 70. The cold fluid entry temperature is 20 and the leaving temperature is 45. What is the value of LMTD? This is delta T1. This is delta T2. Can you find out LMTD? I want everyone to solve for LMTD first. I am using the LMTD approach. Even though it is mentioned to use the NTU approach, but because I feel LMTD approach is little simpler. If all the terminal temperatures are given to you, then you can use the LMTD approach because we are having all the terminal temperature given in the question. Then we can go with the LMTD approach. Isn't it? If any of the temperature would have been missing, then we should have used the another approach. Delta T1 minus delta T2 upon natural log of delta T1 by delta T2. Can you find out what is delta T1? 70 minus 20, that is 50, minus what is delta T2? That is 25 upon natural log of 50 by 25. That will give you LMTD. So delta Tm, mean temperature difference between hot fluid and cold fluid, is, what is delta Tm? Question number 7. What is delta Tm? I think delta Tm should be 36.06 degrees Celsius. Once you get L delta Tm, then Q is equal to U into A into delta Tm. So A will be equal to Q upon, what is the heat transfer rate? 100 kilowatt, 100 into 10 to the power 3 upon U. U is 3100 into delta Tm 36.06. Do solve it, you will get area in meter square. What will be the area in meter square? What will be the area in meter square? Are you getting option A? Are you guys getting option A or not? Isn't it option A? That is one approach. If you use the effectiveness NTU approach, if you use effectiveness NTU approach to find out the area, effectiveness NTU approach, effectiveness is given by Q upon Q maximum, that is equal to Q upon CC, C minimum into TH1 minus TC1, isn't it? So Q is already given to you. What is Q? 100 kilowatt. So it will be 100 into 10 to the CC is not given. Is it given? CC is not given. So what you can do is, because the heat capacity rate for the cold fluid is not given in the question, so Q could have been written as CC into TC2 minus TC1. This could have got cancelled out. That is 45 minus 20 upon TH1, that is 70 minus 20. 45 minus 20 upon 70 minus 20. That is the effectiveness. What is the value for the effectiveness? 0.5. That will be the effectiveness. And then because it is condenser, when there is a phase change, then effectiveness is given by 1 minus e to the power minus NTU. So NTU can be calculated from here. Can you find out the value of NTU? NTU will come out to be 0.6931. That is UA by C minimum. Again we require C minimum. That is CC. You could have calculated CC from here. What is CC? Q is equal to CC into TC2 minus TC1. Q is equal to 100 into 10 to the power 3 is equal to heat capacity rate for the cold fluid into TC2 minus TC1. TC2 is 45 minus 20. Find out the value of CC. That is equal to 4000 watt per Kelvin. That is C minimum. So NTU is given by, or area will be given by NTU into C minimum upon U. What is NTU? 0.6931 into C minimum is 4000 upon overall heat transfer coefficient is already given as 3100. That will be the answer meter square. If you solve this way also, you will get the same result, 0.894. You will get the answer as 0.894. I hope that both the methods are clear to you. Is this clear to everyone? Let us move to the next one, question number 8. Heat is conducted at a steady state through a solid wall with temperature gradient of -5 degrees Celsius per centimeter. Heat is conducted at a steady state through a solid wall with the temperature gradient of -5 degrees Celsius per centimeter. The thermal conductivity of the solid being this, thermal conductivity K is given, dt by dx is given, which is negative. If the heat is exchanged by radiation, there is a conduction here, and the same heat will be radiated from surface to the surrounding at 330 degrees Celsius. Then the surface temperature of the solid, or we need to find out this Ts. So conduction should be equal to radiation. Q conduction should be equal to Q radiation for a steady state. For the steady state, Q conduction should be equal to Q radiation. What is Q conduction? Minus K into area normal to the direction of heat flow into dt by dx is equal to Q radiation is equal to sigma into A into surface temperature to the power 4 minus T infinity to the power 4. Here we need to find out Ts, area getting cancelled out. So Ts is equal to T infinity to the power 4 plus minus K into dt by dx upon sigma and whole to the power 1 by 4. That will give you the answer. Temperature has to be in Kelvin. Temperature should always be in Kelvin. That is the absolute temperature. We should always use the absolute temperatures. What is the surface temperature of the solid? What is sigma? Sigma is 5.67 into 10 to the power minus 8 watt per meter square Kelvin to the power 4. Put the values. This negative sign will get cancelled out with this. So it can be converted into Celsius per meter. And if you will do the calculation, the answer to question number 8 should come out to be 674.4. Please do the calculation. T infinity will be equal to 30 plus 273 Kelvin. 30 plus 273 Kelvin. So put the values. 303 to the power 4 plus can you do the calculation and find the answer? Is your answer matching or not? Thermal conductivity is 22.5. dt by dx is 500 degrees Celsius per meter. Plus 303 to the power 4 to the power 1 by 4, that is 0.25. 674.38 will be the answer. C is the correct answer. This will be the expressions to be used. The next question, question number 9 on the screen. An air heater uses steam condensing at 110 degrees Celsius to heat air at the rate of 5 kg per second from 20 degrees Celsius to 75 degrees Celsius. Steam is used, so there is a phase change. There is a condenser, hot fluid. Heat steam is the hot fluid that undergoing a phase change. Initial temperature, the temperature of steam is 110 degrees Celsius. The cold fluid is water. Water is the cold fluid. Sorry, air is the cold fluid, which is moving at 5 kg per second from 20 degrees Celsius to 75 degrees Celsius. It is desired to double the airflow at the same time. It is desired to double the airflow at the same time, achieve air outlet temperature of 75 degrees Celsius by increasing the steam condensing temperature. So the second condition is, what is the steam condensing temperature when the mass flow rate becomes 10 kg per second? That is the question. That will be the question. You need to find out TH. This is the first case. This is the second case. So from the first case, if we want to calculate the effectiveness or NTU, we can say, just a second. Can you solve it? In first case, effectiveness is equal to 1 minus NTU to 1 minus e to the power minus NTU minus N1, isn't it? And what is the effectiveness? That is equal to CC into 2C2 minus TC1 upon C minimum into TH1 minus TC1. C minimum, CC getting cancelled out. So that is equal to TC2 minus TC1, 75 minus 20. 75 minus 20 upon TH1 1 and 10 minus 20. So from here you can find out N1. N1 will come out to be 0.9445. And what is NTU? That is UA by C minimum. So it increases, it becomes twice. C minimum is equal to M dot C, that is CC, M dot C into CC. So this will be increased, this will become twice. So N2 will become twice of N1, isn't it? Sorry, N2 will become N1 by 2. N2 will become N2 will become N1 by 2, isn't it? Because NTU is equal to UA by C minimum, and C is the mass flow rate into specific heat. Specific heat remains constant, mass flow rate changes, so that is why NTU changes. So it is 0.9445 by 2. Now in second case, effectiveness, that is 1 minus e to the power minus N2. You can find out N2 is equal to, then we will write TC2 minus TC1, CC into TC2 minus TC1 upon C minimum, that is again CC into TH2 minus TC1. Put the value, these two will get cancelled out. So 1 minus e to the power minus 0.9445 by 2 is equal to 75 minus 20 upon TH2 minus 20. So that will give you the answer for TH2. That is how you can find out TH2. That is how you can find out TH2. What is the answer for TH2? It should come out to be 166.2, isn't it? Please check and do let me know if you are getting 166.2 or not. 0.9445 divided by 2, that is NTU. E to the power minus this 1 minus the 55 divided by answer, then plus 20. will give you the final 166.12. 166.12 will be the answer, isn't it? Next question, question number 10. Very simple question. From the basics of radiation, for a thin copper plate, the total emissive power is given as 80 watt per meter square. What is the total emissive power? That is E. 80 watt per meter square, that is flux. Irradiation, what is irradiation? That is the incident radiation, 190 watt per meter square. If the thin plate has reflectivity rho is equal to 0.6, absorptivity is 0.1 and transmissivity is 0.3, then the radiosity is, what is radiosity? J, E plus rho G. Very simple. That is 80 plus, what is rho? That is 0.6 into G, that is 190, will give you the answer, watt per meter square. Question number 10. 194 will be the answer. 194 will be the answer, isn't it? The next one, question number 11. The next question number 11. The net radiation from the surfaces of two parallel plates of emissivity 0.7 each. There are two parallel plates. F122 is equal to 1, isn't it? Because F11 is 0. Epsilon 1 is equal to epsilon 2 is equal to 0.7. Maintained between two temperatures T1 and T2. The temperature T1 and this is the temperature T2 is to be reduced by 85 times by using radiation shields of emissivity 0.05 in between the plates. If there are shields placed having the emissivity 0.05, the number of shields required is, we need to reduce by 85 times. So Q1 is without shields and Q2 is with shields. Let me assume. So according to the given question, Q1 by Q2 is equal to 85. Q1 is more than Q2. So Q2 becomes 85 by Q1. Q2 becomes Q1 by 85. Q2 becomes Q1 by 85. That is the given question. And what is Q1 by Q2? That is thermal resistance 2 upon thermal resistance 1, isn't it? Because Q is inversely proportional to thermal resistance for the same temperature, for the same thermal potential. So if we want to write RTH2 upon RTH1, then we will write Q1 by Q2, that is 85, is equal to, what is the thermal resistance 2? 1 upon epsilon 1 plus 2n by epsilon 3 plus 1 upon epsilon 2 minus n plus 1. That is R2. 1 upon epsilon 1 plus 1 upon epsilon 2 minus 1. That is with and without shield. With and without shield. Can you put the values and get the answer for n? The question is about n. So 85 into, it will be 2 upon 0.7 minus 1 is equal to, again 2 upon 0.7 plus 2n by 0.05 minus n plus 1. Can you find it out? Can you find out the value of n? Can you solve for n? Can you solve for n? How to solve for n? It should be around 4. The number of radiation shields should be around 4, isn't it? Because epsilon 3 is different from epsilon 1 and epsilon 2. That is why we need to use this formula. Are you able to do the calculation part? 2 divided by 0.7 is how much? 2.85 minus 1 into 85. So n should come out to be around 4. The number of radiation shield should be around 4. The next question, to measure the effective thermal conductivity of an insulating material, K need to be calculated. A spherical shell of inner radius 26 centimeter shell, it means a hollow sphere of inner radius R1 is equal to 26 centimeter, or that is 0.26 meter, and outer radius R2 is equal to 34 centimeter, that is 0.34 meter, was constructed, and a 100-watt electric bulb is placed inside the center. So Q is equal to 100 watt. Q is equal to 100 watt. The heat will flow radially outward. At steady state temperature, temperatures of inner and outer surface were measured to be 339 Kelvin. T1 is equal to 339 Kelvin and T2 is 311 Kelvin respectively. What is the thermal conductivity of the material? It is simply the question from the hollow sphere. So Q is given by 4 pi K R1 R2 delta T upon R2 minus R1. We can find out the value of K from here. K is equal to, what is Q? That is 100. What is R2 minus R1? That is 34 minus 26. 0.08. Then upon 4 pi into R1, that is 0.26, into R2 0.34, into delta T, that is 339 minus 311. Do the calculation, you will get the value of thermal conductivity. What will be the thermal conductivity? Question number 12. Are you getting option D or not? 0.257. Are you guys getting option D or not? 100 into 0.08, that is 8 divided by 4 pi 0.26 0.34. What is 339 minus 311? That is 328. 0. It is not coming correct. How much is the answer? Q, that is 100. .34. Radius are given 0.08. That is 100. 4 pi. Okay, 28. It will be 28. Are you getting 0.257? Yes. Yes, H4B. Four pi 0.34 into 0.26 into 28. 0.257. Yes. Question number 13. The next one. A heat flux Q is 6000 watt per meter square at the surfaces of an electrical heater. The heater temperature is 120 degrees Celsius, where it is cooled by air at 70 degrees Celsius. This is the electrical heater. (70°C) is the fluid air temperature, and the heater temperature is 120°C. If the power required is such that Q becomes 2000, then the new heater temperature will be Ts new. The question is very simple. Q is the mode of heat transfer will be convection from the heater surface to the air. So Q is given by HA into delta T. H will remain constant because there is no change in the fluid. So Q will be directly proportional to delta T. So Q2 upon Q1 is equal to delta T2 by delta T1. What is delta T2? That is Ts2 minus 70 upon 120 minus 70, and Q2 by Q1 is 2000 by 6000. Equate these two, you will find out Ts2. What is the answer for Ts2? Question number 13. Option C, isn't it? 1 by 3 into 50 by 3. 1.66. 16.66 plus 70. 86.66 is the answer. C will be the answer. The next one, question number 14. The temperature gradient is a temperature gradient for a flow over a flat plate is given by this expression. The temperature, it is actually the temperature profile. The temperature profile for flow over a flat plate is given as this. If the thermal conductivity of the fluid is 0.03 watt per meter Kelvin, the value of convective heat transfer coefficient H is. So how to solve for H? In no slip region, there will be conduction. So Q conduction is equal to Q convection. So for no slip region, there is a conduction. So we can say minus K of fluid into A into dt by dx or dt by dy. That is the interface at y is equal to 0 is equal to H into A into delta T. That is Ts minus T infinity. Area getting cancelled out. From here we can find out H. What is the formula for H? H will be minus thermal conductivity of fluid dt by dy at y is equal to 0 upon delta T, that is Ts minus T infinity. We need to find out dt by dy at y is equal to 0. So if you do the differentiation, what is dt by dy? So we can say it should not be x, it should be ty. It is Ts minus T infinity, Ts minus T upon T minus T infinity. Sorry. This is the expression. Ts minus T upon Ts minus T infinity is given by this expression. Sin pi y upon 0.015. So can you find out dt by dy at y is equal to 0? Do the differentiation. It will be minus Ts minus T infinity. What is the differentiation of sin theta? That is cos theta. So it will be pi upon 0.015 into cos of pi y upon 0.015. For y is equal to 0, it will be 0 cos 0. What is cos 0? That is equal to 1. Cos 0 will be equal to 1. So dt by dy at y is equal to 0. If you put the values, so H will be equal to minus, what is the thermal conductivity? 0.03 into minus will get cancelled out. If you put the value, it is also having a negative sign. It is also having a negative sign. So it will be Ts minus T infinity into pi upon 0.015 upon Ts minus T infinity. These two will get cancelled out. Put the value and solve for H. .03 into pi divided by 0.015. 6.28 will be the answer. Option B is the correct answer. For question number 14, option B, 6.28 will be the answer. Isn't it? Question number 15. A vertical surface 5 meter high is at 80 degrees Celsius and is surrounded by air at 20 degrees Celsius. This is T infinity. This is Ts. The value of average heat transfer coefficient at a location where Grashof number is 10 to the power 8 is 48.3. H is given as 48.3 if Grashof number is equal to 10 to the power 8. The average heat transfer coefficient at a location where the Grashof number is 10 to the power 4. For Grashof number to be 10 to the power 4, what is the value of H? So we need to develop a relation between H and Grashof number. And because as Grashof number is less than 10 to the power 9, so the motion is laminar. It is for free vortex, free convection. It is for the natural convection, natural or free convection. The question is from the natural or free convection. If Grashof number is less than 10 to the power 9, the motion is laminar. So Nusselt number, which is H into LC by KF, Nusselt number is directly proportional to Grashof number into Prandtl number to the power 1 by 4. For laminar motion, it is 1 upon 1 by 4. For turbulent motion, it is 1 by 3. So Grashof number is given by rho square. So G beta delta T LC cube by mu square. That is the Grashof number. So here H is proportional to, so what we can say, H is proportional to Grashof number to the power 1 by 4. If you are able to develop this relationship, H2 is equal to H1 into Grashof number 2 upon Grashof number 1 to the power 1 by 4 will give you the answer. What is the answer? Question number 15. Are you getting 4.83 or not? Grashof number 2 is 10 to the power 4. H1 was, what is the value of H1? That is, H1 is 48.3 into 10 to the power 4 upon 10 to the power 8 to the power 1 by 4. So it will be 4.83 watt per meter square Kelvin. 4.83 will be the answer. Question number 16. The next one. Water enters a counterflow heat exchanger at 15 degrees Celsius. It is a counterflow heat exchanger. The water is entering at 15 degrees Celsius, flowing at the rate of 1300 kg per hour. It is heated by oil. So water is the cold fluid which is getting heated. Oil is the hot fluid. Specific heat of oil is given, flowing at the rate of 550 kg per hour from the inlet temperature of 94 degrees Celsius. The actual heat transfer from oil to water if the effectiveness is 0.94. It is the counterflow heat exchanger. This will be the temperature profile for counterflow heat exchanger. Water is the cold fluid which is at 15 degrees Celsius initially, flow at the rate of 1300 kg per hour. It is heated by oil is the hot fluid. Specific heat of oil is given 2 kJ per kg Kelvin, flowing at the rate of 550 kg per hour from the inlet temperature of 94 degrees Celsius. When the inlet temperatures are given, this is TH1, this is TC1, then we can go with the effectiveness method. For effectiveness method, we need the inlet temperature for both the fluids. We need to find out Q. Q is equal to, we know effectiveness is equal to Q upon Q maximum. So it is effectiveness into Q maximum. So Q is equal to effectiveness, which is given. What is Q maximum? That is C minimum into TH1 minus TC1, isn't it? What is C minimum? First of all, find out C minimum. For water, specific heat is given as 4.18 kilojoule per kg Kelvin, isn't it? And for oil, it is 2 kilojoule per kg Kelvin. Find out what is C minimum. 4.18 into 1300. So oil will have CH is C minimum. C minimum is CH. So effectiveness will be 0.94 multiplied by CH is mass flow rate, that is 550 into 550 kg per hour. If you convert it into kg per second, 3600 into specific heat is 2000 into TH1, that is 94 minus 15 will give you the answer. That will give you the answer for Q. Can you solve it? 0.94 into 550 into 2000 into 94 minus 15. Divide by 3600. In kilowatt, it will be 22.69. 22.7 will be the answer. 22.7 kilowatt. 22.7 kilowatt will be the answer, isn't it? 17 and 18 are common data question. A convex gray body denoted by surface 1, it is convex, having surface area of 4 meters square, that is A1, let us say, has emissivity epsilon 1, 0.35 and some surface temperature 680 Kelvin, that is T1. Is completely enclosed by another gray surface denoted by surface 2 having an area, this is A2, has emissivity epsilon 2 and the surface temperature T2. The value of F222 is F222. It is convex surface. Both are convex surface like this. F222 will be equal to 1 minus A1 by A2, isn't it? So that is equal to 1 minus 4 by 36. 1 minus 1 by 9. 8 by 9. 8 by 9. 0.88. C is the answer. C will be the answer. This is surface 1. This is surface 2. We can assume the two surfaces to be an enclosure. The net heat rate Q122 is Q122 is equal to sigma T1 to the power 4 minus T2 to the power 4 upon 1 upon epsilon 1. What is the expression? 1 minus epsilon 1 by epsilon 1. It will be sigma into A1. Sigma into A1. Then it will be 1 minus epsilon 1 upon epsilon 1 A1 F122 plus A1 by A2. What will be the expression? Can you develop the expression? A1 by A2 1 minus epsilon 2 upon epsilon 2. This will be the expression. So this will get cancelled out. So it will be 1 by epsilon 1. Sigma 5.67 into 10 to the power minus 8. A1 is 4. Then T1 to the power 4 minus T2 to the power 4. 680 and 680 and 310. Divide by 1 by epsilon 1. This will get cancelled out. So 1 by what is epsilon 1? That is 0.35. And what is epsilon 2? 0.75. 0.35 plus 4 by 36. 1 minus 0.75 by 0.75. That will give you the answer Q1 to 2. Can you find out Q1 to 2? Please check. Your answer should be option B. Are you getting option B? It should be option B. .33 divided by 9 plus 1 by 0.35. And then it will be 5.67 into 10 to the power minus 8 into 4 into 680 to the power 4 minus 310 to the power 4, then divide by answer. 16.03 kilowatt will be the answer. The next one is linked question number 19 and 20. The main trunk duct of an air conditioning system is rectangular in cross section. It is rectangular cross section, which is 400 mm by 800 mm, and has air at atmospheric pressure and at 20 degrees Celsius flowing with a velocity of 7 meter per second. The air is flowing with 7 meter per second. The velocity is given as 7 meter per second. The relevant properties are of air as kinematic viscosity, alpha, it is meter square per hour, and the thermal conductivity of air are given. The value of Reynolds number. What is Reynolds number? Rho V dH by mu, or we can write V into dH by kinematic viscosity. So the Reynolds number will be equal to velocity is 7. What is the hydraulic diameter? That is 4A by P. 4 into 0.4 into 0.8 divide by twice of A plus B, 0.4 plus 0.8. That will give you the hydraulic diameter. Put the value of hydraulic diameter. What is the hydraulic diameter? First calculate the hydraulic diameter. .4 plus 0.8, 1.2. So 2 into 0.4 into 0.8 divided by 1.2. Hydraulic diameter is 0.53. So 0.53 divide by kinematic viscosity 15.06 into 10 to the power minus 6. Can you guys hear me? Am I audible and visible to everyone? Hello, hello. Hello. Yes. Now the Reynolds number will be how much? Calculate the Reynolds number into 7 divide by 15.06 into 10 to the power minus 6. So it will be 0.24. So 24.8 into 10 to the power 4. 24.8 into 10 to the power 4. Isn't it? Question number 19, option B is correct. B is the answer. And the last question for the day is, what is the convective heat transfer coefficient? So because it is, we need to find out the convective heat transfer coefficient. How? It is 24.8 or 2.48 into 10 to the power 5. 2.48 into 10 to the power 5. It is less than 5 into 10 to the power 5. It is less than 5 into 10 to the power 5. It is actually internal flow, sorry. It is the internal flow. It is not external flow, it is the internal flow. So because it is greater than 4000, this is the question from the internal flow. Because it is greater than 4000, then we can say the flow will be turbulent. For turbulent flow, Nusselt number based on hydraulic diameter is equal to H into dH by Kf is equal to 0.023 into Reynolds number to the power 4 by 5 into Prandtl number to the power 0.4 into Prandtl number to the power 0.4 because surface temperature is greater than fluid temperature. So if you put the value, you will get the answer for H. That is your assignment. Please try to find out the answer for H. The correct answer will be option C. And I am giving you one more question for the assignment. Try to solve it at home. This is your assignment question. And I will see you in the next session. Till then, enjoy, take care, have a good day and a great future ahead. Thank you guys. Thank you very much for being part of this session. Jai Hind.